In this video lesson, we're going to work out how a formula can be used to work out compound interest. Up until now, we've done it, first of all, a very long way. Secondly, we worked out how to do it using a multiplier, the constant multiplier, which we're going to use here. But in the end, there is a formula that can help us work these out. So let's have a look at this question. The question says, and I'm going to highlight things so that we can pick it up. It says, find the amount to which $5,000 will grow. $5,000 is the amount invested, and it's invested for 4 years at 7% per annum, and it's compounded every year. So the first question we're going to look at is what this actually turns out to be. All right, so we're going to use our constant multiplier. The balance at the end of year 1 is going to be whatever our balance is, that's $5,000 to start with. And we're going to times it by our constant multiplier. Now remember, it's 100% plus our interest rate, which is 7%. And if we convert that, that's 1 plus 0.7, or sorry, 0.07. And the final multiplier is 1.07. So that's what we're going to multiply each time. And it makes it very easy to do. What it tells us is that the balance at the end of the year is going to be $5,000 times that. Now we're actually not going to work that out. We're just going to imagine we've got the answer for that. Because what we're going to do now is to say, well, the balance at the end of year 2, now let's think about this. The balance at the end of year 2 is going to be that amount, so we'll write it down. Times 1.07. We're going to put that in brackets because whatever that is, if we times it by 1.07 again, you'd have to agree that that's going to give us the balance at the end of year 2. Because if we had have worked that out to be a number, it would have gone there, and whatever that number was, we multiplied by 1.07. Now, there's a pattern happening here. I'm going to write this out. If you notice that this is 1.07 and that's 1.07, what I get is this. I get $5,000 times by 1.07. Now notice there's 2 of them, so we're going to make that squared. Now that 5,000 is there, 2 of those multiplied is that, and you're going to start to see a pattern come together because remember we're working towards a formula. Alright, so let's have a look now at the balance at the end of year 3. Alright, so what is it going to be? It's going to be all of this, because remember this here is the balance at the end of year 3. So if you like, it's this amount. Let's write it down. $5,000 times 1.07 squared. Now that is definitely the balance at the end of year 2. So it's going to be that amount, and all we have to do is to times it by 1.07 again to get the new end of year balance. And if you look at what's happening here, you're starting to get a pattern. It's the starting amount times 1.07. Notice it's now, there's 2 of those and another 1, so that's 3. Now you'll notice year 3, and that's to the power of 3. So we're taking our balance, and because we keep timesing it by this amount that we call the compounding multiplier, the multiplier effect, we get this sort of answer coming out. All right, so last one. Here's our balance at the end of year 4. So we know that the balance at the beginning of year 4 is this amount here. It just hasn't been worked out completely. It's just in a form to prove a point, as you'll see. So I'm going to put this here, $5,000, what we started with. We've used the multiplier once here, twice here, 3 times here. So if I put the 3 here and then times it again the 4th time, because it's now 4 years, you'll notice that the final answer is 5,000 times 1.07 to the 4. So in the end, we now know that after 4 years, that is going to be the answer. Now you could put that in your calculator and it would come out with the perfect answer. You can try that. But let's have a look at this next question. It says, what do you think the balance will be after 10 years? Well, if you use this pattern, you just think ahead a little bit now. Think about the pattern. Think about what you think the answer might be. Remember, this is after 2 years, 3 years, 4 years. I hope you can see that the balance after 10 years can actually be worked out really, really quickly. The balance after 10 years is going to be $5,000 times the multiplier, which is 1.07. And how many times did we apply the multiplier? 10 times. So we times it to the power of 10. And if you work that out, that will be the balance after an investment of this amount of money, $5,000, for 10 years. Nice, easy way to do it. Now, you don't have to do any more working with that, but what it leads to is on the next section of your work. Let's have a look at this. Now, I'm just going to move this down a little bit so you can see it a bit better. There we go. Now have a look at the formula for compound interest. There it is. It says in general, and I'll highlight this so we can see it. In general, the amount of money to which your investment, that's P, will grow, that's your principal, if it's invested for N years, and that could be 3 years, 5 years, 10 years, at an interest rate of R, so R could be 3%, 5%, 10%. Compounded yearly is given by this. All right, so the A is how much it grows to, the final value. You just need to have the principal. In the last case, it was $5,000. And there's your 1 plus R to the power of N. R is the interest rate. That's how it's expressed. Remember, you've got to divide it by 100 to the power of N. And this is called the compound interest formula. All right, so we're going to apply this and then you're going to have a go at practicing it. So I'm just going to move it up a little bit so you can still see the formula part of it. And we're going to try it with this particular question. All right, actually I'll move it right up a little bit and I'll write the formula out again when we need it. So here we go, A. Let's read the question. It says, use the compound interest formula to calculate. Well, the formula itself says that A, which is the amount to which it will grow, is equal to P, that's the $10,000, and then it's 1 plus, now we use the R as the interest rate, 4.5 over 100, because we've got to have it as a decimal, and remember N is the number of years. So if we actually put this in to the formula, here we go with the answer. P is $10,000. 1 plus, now the interest rate is 4.5, so we put it up there as 4.5. Change it to a decimal, that's out of 100, rather than just a percentage. And to the power of 8, because it's 8 years. That multiplier, remember, that's our multiplier there. All right, for 8 years. If we put that into our calculator, we get an answer of $14,221.01. You can check that out for yourself. By the way, this is the same as 1.045. That's our multiplier. We had a practice with these, so that's our multiplier to the power of 8. And there's our answer. So quite an easy way to work it out. That's over 8 years. Instead of doing it year after year after year, you can do it in virtually 2 or 3 steps. Now B says, so what was the interest earned? Well, the interest, let's think about it. The interest, I'll put it down here, must equal what we had in the bank at the end, $14,221.01, minus, what would it be? Yep, the amount of money we put in at the beginning, $10,000. And when we work that out, what we've earned is $4,221.01 in interest. So that's a very nice way. If we know that formula, that is a very, very nice way to work out the compound interest that is earned on our investment.